Okay, hello students, and welcome to today's Friday Happy Math Hour. Today I'm going to cover simple and compound interest annuities. Okay, these are the topics covered. Simple interest comes from section 5.1. Compound interest comes from section 5.2. Future value annuities 5.3 and present value annuities 5.4. Okay, so let's start off with simple interest. What is simple interest? Here's a formula for simple interest. It's INT equals to PV. PV stands for present value times R, which is the interest rate, times T, the time. Again, the interest is a fee paid to use someone else's money. The present value is called the present value or the principal. The R stands for the interest rate. And the key symbol is that the number has a percent symbol. And the time is equal to T is equal to time in years. Okay. Now, there's another formula. If you use this formula, there's another formula, which is AV equals to PV plus INT. Now, the other formula derives from the interest formula. For example, the interest formula is PV R times T. Now here, how they come up with the other formula is that on the right side, I'm going to factor out the PV, which is the present value. If you factor it out, what's left? 1 plus R times T. And this can be checked because if you do the distributive property, the present value times 1 will give you the present value. The present value times R times T will give you PV R times T. So these are the two formulas that will be used in section 5.1, and these are called the simple interest formulas. Okay, again, how I tell my students to actually show the work is to put here all the variables, and then from the information that they give you, you can extract the information and put it on its right location. Okay, it's the same as before. This is a sum of the principal and the interest earned, which is the future value, present value or principal, the interest rate, and the time. So there's something that's very important here. You need to know. If months are given, then time will be given months divided by 12 because the time has to be in years. And since there's 12 months to a year, if they give you months, so it's going to be the given months over 12, that will represent the time. And also, the interest rate must be in decimal. So you have to convert percent to decimal. Example, if you have 5%, right? You move the decimal place 2 places to the left and you drop the symbol. So 5% is equal to 0.05. That's crucial for this section here, or for the chapter. Okay, now, let's do an example. Example 1. Hey, participants, if you have any questions as I'm doing the PowerPoint, please feel free to get in the chat and raise your hand up, or just put in the chat that you want me to go over it again, and I'll be able to do that for you. Okay? So, example 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle and how much interest did Martha pay. Okay, so again, so solution. Which formula should we use? Is it the interest formula or the future value formula? Does it matter? No, it does not matter. Okay, I'm going to do this very same example with both formulas, just so you know that it's the same thing. So first, let me start out with the interest formula, which is the INT, which is interest equals to present value times R times T. Okay, so if I'm going to use this formula, then I have to use this one also, because for the future value, I need to, for the total amount paid, I need to use this formula. So these two go together. Okay, so let's first start with the formula on the left, which is the interest formula. So again, I'm going to put all my variables. And like I tell my students, when they're doing this type of problems, they have to put down all the variables here, guys. And this way, if all these are right, that means that they know how to extract the information from the word problem. And they get most of the credit by doing that. And then they get credit also for putting it into the calculator. But this is the most important thing is to make sure that you extract the info and put it on its right location. So let's see what they're asking for here. Martha borrows $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle. So here, guys, we're looking for the future value, right? And also how much interest did Martha pay. So we can start out by finding the interest first. Okay, so if we're looking for the interest, my present value is at $12,000, the money that Martha borrowed. The present value or the principal. It means the same thing. Now, now the R stands for interest rate. The interest rate is very easy to observe because it's a number that has the percent symbol. So the interest rate, R, is 3.5%. But remember, you have to convert it into a decimal. So that becomes 0.035. Then my time, right, is 5, right, because it's already in years, so it's going to be 5. Then all we do is plug it into the formula, right? There's my formula, plug everything in. Here's my present value, which is at 12,000. This is my interest rate, which is 0.035. And the time, T, is 5. And all you do is plug into the calculator, and this is what you get. 2,100. So now, right, so this is the answer for the second part. How much interest did Martha pay? She paid $2,100 in interest. Now, let's see how much money was in the future, right? So for the future value, right, it's going to be the present value plus the interest rate. So Martha has to pay back the original 12,000 plus the interest, which is 12,000 plus 2,100, which would be a total of $14,100. That's how much she has to pay back. So total Martha paid is 14,100, and the interest paid is 2,100. Okay, that's how you do these problems here. Now, you see, guys, a very simple problem, right? But remember, I told you that the formula doesn't matter. So now let's use the other formula, which is the future value formula. So if we use this formula, right? So then we put a V, PV, R, and T. So let's extract the information again. Here, guys, we're looking for the future value, right? Because find the total amount that Martha paid to her uncle. So here, for the total amount, she means in 5 years. So we're looking for the future value. So the 12,000 goes to the present value. Then my interest rate will be the same as before, 3.5%, which equals to 0.035, and the time will be 5 for 5 years. Again, we plug everything into the formula. There's my present value. There's my interest rate, the R, 0.035 times 5 for the time. And just plug into the calculator just the way it is, and you get the future value, which this is a total that Martha paid to her uncle. Okay, now how much of it was interest? So then, right, so then interest equals to future value minus present value. So let's see how much interest Martha paid. So there's my future value where we just got the 14,100 minus the amount that she borrowed, which is a present value. So it's equal to 2,100. You see, students, we get the same thing. Martha paid a total of 14,100, and the interest paid is 2,100. So at times, it doesn't matter which formula to use. Okay, so we have to read the problem carefully, and then you decide which one is better for you. So here I give you two options, and they both got the same result. Now, let's do example number 2. Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough to pay the tuition bill? So which one should we use here? Because here, this is not the present value, so we cannot use the interest formula. We have to use the future value formula because this is the future. She wants to. It says, Mariana, we need to pay a tuition bill of 7,500 in 10 months. So this means that we're going to use this formula here, the future value formula. Okay, so we're looking for the present value. Why? Because she says the dollar amount she needs to deposit today, right? So we're looking for the present value, which is the value today. So then the future value will be 7,500. My interest rate is going to be 1.25%, right? We convert it to a decimal. It's going to be 0.0125. The time, guys, remember at the first or second slide where I mentioned that time is in years, but here they give you months. So it's going to be 10 divided by 12. Okay. Now, there's my formula. Because this formula, these two are the same. This is what the book uses to solve for the present value because we're looking for the present value. I'm going to show you this way, and then I'm going to show you another way. Okay, that I believe it's easier for students, especially if they don't know how to use a calculator. That well. But for now, let's do it the way the book explains it, and also your My Math Lab how they explain it. They will explain it this way. Right, so there's my future value of 7,500. There's my 1. The interest rate will be 0.0125 times this is my time, right, in months. So we do the bottom part first, right? So if we do 1 plus 0.0125 times 10 divided by 12 will give us 1.0104166667. Then we divide this in the calculator, right? So then that's going to give us $7,422.68. So that's my present value. But I want to show you with this very same formula, the original formula, how to do it without stopping and clearing the calculator. Okay? So this is my formula. So I plug everything in how it goes. So the first thing you're going to do is you're going to enter parentheses 1 plus 0.0125 times 10 divided by 12 into your calculator. That's what you're going to get. Then you're going to hit the inverse key. The inverse key means that you're going to multiply by the inverse here, which will be 1 over 1.01041667. That's what the inverse key does. So you hit inverse, and this key is located, I believe, in the first column of your calculator on the TI or TI3, TI4 calculator. Then you're going to, when you press on the inverse key, you should see that right there. That's what you should see when you press the inverse key, which means the inverse of the answer that we got here, which is the 1.0104 and so forth. Then you enter 7,500. Right, so you enter 7,500, and that's your result. Okay, so we get the same thing. I was showing this PowerPoint to my students today, and they like the way everything goes real smooth if you do it this way in the calculator. Okay, after that, I believe after the next part, the next slide, I'll be doing it this way in your calculator, just the way it is like this. And I tell my students that if you're solving for the PV here, you're going to use the inverse key after you enter all this in your calculator. Okay? So let's do another one. It says here, John received a $10 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was $125? So here what we have to do here is read the problem carefully to see which formula we're going to use. If we notice that $10,000 is a present value, that's how much John borrowed. And the 125 is the interest accrued, which means how much interest that this transaction or this loan accrued, which means we're going to be using this formula here because the INT is 125. And the 10,000 will be your present value, and 2.5% will be your R. Okay? You see, we use this one here. Okay, now. So now, Let's do this, right? What is given and what are we looking for? We're looking for the time, right? Because how long means time. We're looking for time. So let's plug everything in. Okay. And there's my interest accrued. Okay, now, so here, guys, if I were to use this one here, the other formula, right? Then I would have to add the 125 plus the 10,000, and that'll be my future value. But the way it was presented, or the way the formula was being stated, this is your best choice here, this formula here. Okay. So then, guys, let's plug everything in. There's my interest accrued. There's my present value. Here's my my R, right, which is the interest rate, and we're solving for T. So if we multiply 10,000 times 0.025 will give us 250. Then we divide by both sides by 250, and it should give us 0.5. So what's my answer? It will be 0.5 years, or half a year, or 6 months. Either answer is correct. Okay. Are you guys okay up to this point? Do you guys have any questions? No questions? Okay. Okay, let me continue then. Now, this is something from section 5.2. Okay, 5.2. 5.2 is compound interest. So this is a formula that we're going to be using, but it's easier to use this one here. If you notice, here we have I, here we have R divided by M. So I is equal to R divided by M. On the formula to the right, we have N as the exponent, and on the formula to the left, we have MT, so N equals to MT. So in other words, you're going to have to write 7 things every time. You see, there's 7 variables. 1, 2, 3, 4, 5, 6, 7. So the V means the future or the maturity of value, which means the future value. The PV stands for principal or the present value. The R stands for interest rate per period converted to decimal as before. But here is the only difference. The M. The M is the number of compounded periods per year. The T is number of time in years. Then the I is equal to R divided by M, the interest rate per period. And the N stands for M times T, which is the total number of compound periods. Okay? So let's put it here to action. So here are my keywords for compound. Okay? So you're going to substitute on your formula, depends on the wording of the problem here. So for example, if the word says yearly or annually, like for example, compounded yearly or compounded annually, M is equal to 1. If it states bi-yearly or semi-annually, M is equal to 2. If the problem states quarterly, compounded quarterly means M is equal to 4. Monthly is 12 because there's 12 months in a year. Weekly, it will be 52. There's 52 weeks in a year. And daily, it depends. If the book says to use 360, then you use 360. If the book doesn't state what they want for days, right, you put 365. So it can be 360 or 365. Most of the time, they use 365. Okay. Now, what happens if it's compounded continuously? Continuously means there's going to be a different formula. So this is a formula for continuously, which is future value equals to present value, e to the R times T. So this is crucial for the next three sections, which is 5.2, 5.3, and 5.4. Okay, so let's start with some examples here. Now, compound interest can be used to invest a certain amount of money without depositing additional money. So in other words, if you had extra money, right, say you had like about $10,000 or $5,000 or whatever the amount you have, and you just have it there at your house, and you want to put it in the bank, you can put it in the bank and earn some interest. You don't have to put no extra money. Just leave that there for the amount you want, and then you receive extra money back, which is money and interest. Okay. So this formula is used for not putting extra money every period. So that's the money that you put in, and that's it. Example. Example 4. It states you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be in your account after 5 years? And how much interest did you earn? Here's my formula, but this is the one that's easier to enter into the calculator. This will be easier. So again, how many things do we need to find? There's going to be 7 things, right? But only one unknown. So let's start with rereading the problem again and see what we're looking for. Here it's saying, right, the last two questions are what we're looking for. The first one is how much money will be in your account after 5 years. So this, it means that we're looking for the amount in the future, right? In 5 years, that's why we're looking for the future value. So the 1,000 is your present value. The 6%, right, will be your interest rate. Convert to a decimal, 0.06. Here we go, compounded quarterly. Quarterly means 4. So M is 4. The time, right, is 5. So it's 5 years. And the I is going to be R, which is 0.06 divided by N, which will be 4. Now, this is if you put this in the calculator, guys, and it gives you something finite, something with an N, then that's what you use for I. But for whatever reason, when you do the R divided by N, and it gives you something that doesn't stop, do not round off. Leave it how it is, because I believe they're going to be asking you to round off to the nearest penny. So if you round off here, well, guess what? You're going to get the wrong answer every time. Even though you're almost there, but except for the pennies, will not be the value that you want. Okay? So again, for example, here I divided 0.06 divided by 4, and it gave me something finite. So that's what I'm going to use for I. And the N is equal to N times T. So 4 times 5, which will be 20. Again, so all we do is put the formula down, right? Plug everything into the formula. The PV is 1,000. The I was 0.015. You see it's down here. And the N is 20. So the N is equal to 20. And all you do is just plug it in the way it is in the calculator, and you get your result. But remember, you're simplifying. Not simplifying. You're rounding off to the nearest penny. So these are my dimes, the 8, and these are my pennies. So then you always go to 2 places. So how do you round off to 2 places? You look to the third place here. If the third decimal place is 5 or more, then you add 1 here, which this is 5. So you can add 1 to the 5, which would be 13.46 and 86 cents. So that's the amount after 5 years. So that answers the first part of this question here. How much money will be in your account after 5 years? So it'll be $1,346.86. Now, how much interest did you earn? Okay. So again, interest earned equals to future value minus present value. So that's my future value, right? What I just earned, and it was 1,000, the original money that you deposit. So you earned a total of $346.86. That's how much interest you earned. So this is like money that you earned for just putting your money in that account. Okay. Okay, now this is called the continuous compound interest problem. Continuous, right? Remember continuous? It was a different formula. So that's my new formula. So let's write everything down. So the future value, you deposit. So we're looking for the same thing as before, right? This is the same problem as before, but except for a quarterly, it's continuous. So how much money will be in your account after 5 years? So we're looking for the future value. So the 1,000 will be your present value. The 6% will be your R, which is the interest, and to a decimal will be 0.06, and the time is going to be 5. So for this problem, all we do is plug everything in. Okay, but be careful, guys. Be careful on your when you put the e to the power of 0.06 times 5. If it's because there's some calculators, guys, that gives you like a parenthesis after you put here like the caret for the exponent, it opens a parenthesis. If you don't put 0.06 times 5 close parentheses, it's going to kind of wrong. Because a lot of students, they actually do it like this, right? And then here they close up parentheses and doesn't give them the wrong answer. So it's wise to always put it in parentheses, right? Like here. So if you have a calculator handy, try it and you should get $1,349, 0.858808 rounds off to $1,349.86. So after 5 years, that'll be the total in the account. So how much interest did you earn? Again, interest earned is future value minus present value. So it's going to be 1,349.86 minus the 1,000 that you borrowed, that you deposited. So it gives you a total of $349.86. Okay. Let's do one more compound interest. Here we go. Okay, this is example 6. It says here, I want to be earning an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Guys, so listen over here. It might be something that's kind of like in real life. Let's pretend that's you, that you want to earn 100,000 when you retire in 15 years. That's what you want your salary to be. Then you have been offered a job that guarantees an annual salary increase of 4% per year. And the starting salary is negotiable, so you can negotiate what you want to start out with. So what salary should you order to meet your goals? So that's my formula, right? So it's easier to use this one. So there's going to be what? Easier to input this is easier to input in the calculator. So there are your 7 things. Okay. So I want to be earning, right? So you want to be earning this amount, right? In 15 years. So this is your future value. So we're looking for the present value because it says here, what salary should I request in order to meet my goal? Request when? Request it right now. So anyway, the first sentence is the key that this is your future value. So we're looking for the present value. Again, we plug everything in. The interest rate will be 4%. Into a decimal will be 0.04. My M is going to be 1, right? Because it says annually here. Annually means 1. M is 1. The T is 15, right? For 15 years. So what's my I? My I is R divided by M. There's my R, which is 0.04 divided by 1 will be 0.04. And my N will be M times T, which will be 1 times 15, which is 15. So now, we plug everything into the calculator. There it is. Okay? Now here, guys, I'm showing you the way the book explains it to you. But right now, I'm going to show you the other way that my students today, because I was going over some of these problems, and they liked it better the way I was showing them with the TID4 calculator. Okay? So anyway, let me show you the way the book explains it. So first, they do the 1 plus 0.04 to the 15th power, which will give you 1.800943506. And what's good about this video, guys, or this recording, is that you can actually try to follow the video. And what you do is make sure that you stop the video, and then you enter that in the calculator to make sure that it's on. That's the answer. And then you continue. And then you stop it again, right? Until you make sure that you're understanding the concept. And this applies for every problem that has to do with compound interest. Okay, so this is not that challenging, guys. It's if you follow what I'm doing here, you guys should be doing well in this section here. Then we divide both sides by 1.800943506, right? So then this is my present value. Round it off to a nearest penny will be $55,526.45 per year. So in order to meet this right here, right? To meet this person's salary, right, which is negotiable, he or she needs to ask for this amount per year. Then there's going to be a 4% increase every year. So this is the amount that this person has to ask for. Okay. Now this is what I was showing my students today in class. Is your way to use your TI-83 or 85 calculator, right? So we get the info from here, right? After we extract the info, right, we bring this down here. And here's how you do it in the calculator. You're going to input parentheses 1 plus 0.04 plus parentheses to the 50th power, right? Then you're going to enter. So this is what you should see on your screen. 1.800943506. Then you're going to hit the inverse key. The inverse key is this key here in your calculator. Okay? When you hit that, this is what you should see on your screen. You should see the answer to the negative first power. This is what you should see here. Then you're going to enter the 100,000. This is what you get. You see, guys, you get all this without leaving the calculator in a steady flow, like a smooth, steady flow on the calculator, without actually stopping the calculator and trying to reset it to enter the information. See, guys, there's your answer. The formula from the book, they like to use this formula. And actually, this formula derives from the original formula here. Because to solve for PV, don't you divide both sides by 1 plus I to the nth power? So it'll cancel on the right side, and then you have this on the left side. So this is another formula that they use. Okay? But like I said, in my opinion, this is the easier way to do it in your calculator. And why do I come up with the easier way? Because when I was taking this course, it was challenging because I was real naive with using calculators, and I had to write everything down, like here, everything down. And then somebody showed me how to do it in the calculator, like I'm showing you now. And to me, it seemed very, very simple to do. So I figured this is the way that I'm going to show you guys. But like I said, you can use any way you want, right? Any method, the way the book does it, or follow the examples from my math lab, or you can do my way. But the important thing here is for you to use whatever is easier for you. It's not about me. It's not about the book. It's about you. So you decide what you want to use. But from now on, I'm going to be using it this way, because my students also, they voted today in class, and they said this is easier to use, okay, by using the inverse key. Okay. So now this comes from 5.3. This is called the future value of an ordinary annuity. And these are the formulas. The formula on the left is the same thing as the one on the right, because remember, the R divided by M stands for I, and the M times T stands for the N. So this formula on the right seems a lot simpler to use, and it is when you plug into the calculator. Okay? But again, anyway, we always have to find 7 things. 1, 2, 3, 4, 5, 6, 7 for every problem from 5.2 to 5.4. So let's see what everything is. Okay, future value ordinary annuities can be used to accumulate funds for some time in the future. You must set regular deposits during that specific time. So here, guys, what it means is that these can be used to invest money, but you have to set up the account that you're going to deposit like the same amount of money every period, like every month, every quarter, every year. But you have to set the account that you're going to put in the same amount every time. Examples. I like to share these examples with my students, and these examples I just made them up, guys, because these kind of relate to our regular lives. Let's say, for example, say you have a real good job, right? Or say after you graduate and you start making good money, say you get a real good job, and then say after you pay all your bills and everything, you have like an extra $1,000 left over every time, and say this $1,000, they don't affect you at all; they're just there, and you can actually you can save that much money, right, without affecting your lifestyle. So then you decide to put it into an account, right? So let's see here. Let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? This is an example that I'm going to show you right now. Also, another example can be Also, the example. I came up with an example because the example will probably happen to you guys, because when you guys come to school, right? Most of us, when we're in school, we get financial aid, right? Because we couldn't afford college. Like I think like 75 to 80% of students at EPTC, they get financial aid, which is good, right? Because if it wasn't for financial aid, more likely we wouldn't afford to come to college. So you guys come to college, right, to make money, right, to get a better, get a better job, and then make a better life of yourself. So more likely, when your kids, if you have kids, when your kids turn 18 or 20, right, they won't qualify for financial aid no more, or maybe partial. But why am I saying this? Because more than likely, you guys are going to be making a lot of money that your kids do not qualify for financial aid. So this example here, this formula can help you actually try to save money for your kids when they turn 18. And here's a scenario. Let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure that you have enough money in 18 years for your child, it's supposed to be for your child to attend college. Okay? So I'm going to go over these two scenarios on my next examples. Here we go. Again, you can afford to say, right, the same question as before. Okay, so again, this is my formula. I'm going to put down those 7 things. And I tell my students that it's crucial to do it like this, guys. So I guarantee, guys, if you guys do it like this, your professor is going to like that, because this means you're not all over the place, and you actually have organized data there, and then you extract all the info from the word problem into the category that goes here. If you do this, guys, I guarantee your instructors are going to be real happy because of the work that you're doing. Okay, but anyway, let's see what we're looking for here. You can afford, right? So here, how much money will you have in 20 years? So here, that means that we're looking for the future value, right? So that's what we're looking for. So then, right? So then the 1,000 is are your payments. Your interest rate is 3%, which will be 0.03. The M is how many times it's compounded. So it's compounded, right? This will be every month. So the M is equal to 12. The time will be 20. What's my I? My I will be R divided by M, which will give you 0.0025. And the N is M times T, so it'll be 12 times 20, which I believe will be something like 240. So now all you do, guys, is plug into the formula. Okay? So now, how do we do this, guys, right? Again, we do the top first. We do the numerator first, the 1 plus 0.0025 to the 248th power minus 1, and it should give you 0.82075499953. Then we divide it by 0.0025, and we get 328.3019981. Then we multiply that by 1,000, and this is what we get. Round it out to the nearest penny, so we get $328,302. That's how much will be in the account after 20 years. Okay, now let's do this. So how to use calculator without clearing or stopping once any flow until you reach your answer. So again, you input here the numerator, parentheses 1 plus 0.00. Right, divided by. Then you're going to enter 0.0025. Then you should see this in your screen, the number in black. And today, when I was going, to some of these with my students, they just loved the way I did this, and they were saying that they were able to follow, because here they guarantee that they're doing everything right. Okay, so after you get this answer right, you're going to press on the times key, because it's going to be times the 1,000. But before you do that, you should see this on your screen. This answer times, then you enter the 1,000, so you get the same answer as over here. So that's how much money. Okay, now, so how much money did you invest? So here's saying, guys, how much money they came out of your pocket. Here's how you find that out. Right? There were 240 payments of $1,000 each. So in other words, the amount that came out of your pocket will be the 240 y equals the payments times the amount of the payments. So it becomes, so you put in 240,000 in the account in 20 years. So wow, but this is not 240,000. That means that this is the amount that you earned in interest. I mean, if you subtract 240,000 minus the 328, 302, that will give you the amount you earn in interest, which is $88,302. So that this amount is what you got like for free for actually opening this account here, opening this type of investment, which is not bad at all, guys. And right now, this is a little bit high of what it's going for now. When I was growing up in the 80s and 90s, the interest rate that they will give you will be like 9 or 10%, but that's outrageous compared to now. Now, the highest I've seen is like 2.8, 2.9, depending. 3 is kind of the going rate. This will be a good rate these days. Okay. So now, let's do another example here. Okay, now, example number 8. You are planning on sending your just born child to college when she turns 18. You want to have 250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? So again, the future value formula will be the same as before. Okay, again, we put here 7 things, and as I tell my students, that remember the lucky 7, right? There's 7 here's 7 variables, right? That you need to keep account for. So here we go. What are we looking for? You're planning on sending your child to college, right? You want 250,000 in an account for 18 years. So this is the key, that this is your future value because you want this amount in 18 years. Okay. So then we're looking for the payment. How much money must you deposit at the end of, right? So these are the payments here. So we're looking for the payments. The 250,000 will be your future value, and the rest, guys, right? By now you should be able to extract the 5%, right? The symbol, the percent symbol means it's going to be your interest. You convert it into a decimal, which would be 0.05. Compounded quarter, right? Here's a keyword for quarterly, means 4. M is 4. The time is 18 years, so T is 18. The I will be the R divided by M, 0.05 divided by 4, which will give you something like 0.0125. And the N is M times T, will be 4 times 18, which will be 72. Again, you put everything in the formula, there it is. But here, guys, like I told my students, we're looking for payments, so that means we're going to be using the inverse. Okay, so here's how you do it in the calculator. You're going to input what's here in the numerator, just the way it is. You should get the number in black, which is 1.445920268. This is what you should see on your screen. Then, right, then you're going to put the division key, right, because you're going to be dividing. You follow this right here, the division. And then you're going to enter, right, after you press the division key, you should see this in your screen. Answer with a symbol right there. Then you enter the 0.0125. Then this is what you should see on your screen. The 115.6736.215. So after you do that, right, you hit the inverse key, right? You're going to press on the inverse key because we're looking for the payment. Then after you do that, this is what you should see on your screen. Answer to the -1. Then you enter the 250,000, and this is what you get. So then rounded out to your nearest penny is going to be 2161.25. So these are your monthly payments. Okay. Okay, now check this out. How much money must you deposit at the end of each quarter? So you're going to deposit this. These are your payments. That's how much you want to put in every 3 months, because every quarter means every 3 months. Now this is extra information. Okay. How much money did you actually put in out of your pocket? So we multiply the number of payments, which is 72, multiplied by the payment. You actually put in $155,610. If you notice, right, that this amount in blue came out of your pocket, which is $155,610. So then how much money did you make in interest? So we subtract the total that came out of your pocket, subtracted from the 250,000. So 94,390 you got from interest. So this is how much money you earned, which is not bad at all, guys. Right? But again, 5% is right now it's a little bit too high. So try to use this very same format, but use instead of 5%, use something like 2% or 3%. That's more of the going rate at this time. But anyway, guys, this is how you can decide how to use math and I mean to make investments or to try to save money and stuff like that. Now, this other formula counts for present value of an ordinary annuity. And again, it's better to use this formula here on the right. Again, there's 7 things, but now it's present value. These are the payments. What's the difference between this one, the present value, and the future value? For this formula here, for the present value of an annuity, it's how much money you want to borrow from the bank right now. That's why it's called the present value. How much money are you going to borrow from the bank or from a company that's going to lend you some money? Okay. Here are scenarios what they use for. Most common use of present value ordinary annuities are for purchasing an expensive item such as a vehicle or a house. As students, these are the most important and the most expensive investments that we're going to make in our lifetime. Right? We always want to buy a new car. We always want to buy a new house. So this formula will help you understand your payments and how much money extra you're going to be paying and all that stuff. Okay. Examples. You want to purchase a car. What are your monthly payments and how much will you end up paying? You want to get an idea of the process. Okay, here, this is crucial here, guys. If you want to buy a house, okay. So you want to get an idea on the process of purchasing a house. The most important thing, guys, they're going to ask you is here are the key factors. You must have a job. No job, nobody's going to lend you nothing. So you must have a job, right? And depending on your income, depends on how much you qualify for. You must also have very good credit, or at least decent credit. The better the credit, the lower the interest rate. Okay? The higher your credit score, the lower your interest rate will be. The higher your credit score, the lower your interest rate will be. Also, get pre-qualified for a maximum amount of the loan. Because this is crucial, guys, because if you're going out looking for a house, right? If you're not pre-qualified, you're just wasting your time. Because if you qualify for say for something for 150,000, and you're going crazy looking at houses that cost over 200,000 or 300,000, then when you get something or when they show you something that you qualify for, you're gonna feel disappointed because you got used to looking at those real nice properties. So after you look at the real nice properties that are out of your budget, then nothing seems you don't want to buy nothing because nothing seems what you want to buy because you were exposed to those very expensive houses that were out of your reach. So the first thing is to get pre-qualified. This way, the agent takes you to houses that you can afford. Okay? Okay, now, let me do here this example here. Let me first do the example of the car, then we'll do the example of the house. Example 9, you buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? How much interest do you pay? Okay, let's find out. There's my formula. Again, there's 7 things, right? 7 things that you have to keep into account. So we're looking for the monthly payment, right? So we're looking for the payments. So how much money are you going to borrow from the bank, or the company, or the auto company are going to finance you? Is 26,750. Interest rate, right, is 4.2%. You convert it into a decimal, so it's going to be 0.042. Okay. Then the M stands for compounded, right? Most of the times when it comes to houses and cars, right, expensive items, you have to put in like monthly payments. So the M will be 12. There we go. The time is 5 years, so it's going to be 5. So the I will be the R divided by M. We get something like 0.0035. And the M will be M times T, which will be 12 times 5, will give you 60. So just plug everything in the calculator. Right, there's my formula. So let's begin by using what I taught you how to do it with a steady flow in the calculator. The first thing, right, we're going to input 1 minus 1 plus 0.0035 to the negative 60th power. So the number in black is what we get, 0.1891185.031. This is what you see on your screen. Then you're going to hit the division key. After you do that, this is what you see on your screen, on your calculator, the answer right with the division symbol. Then you're going to enter 0.0035. You're going to put 0.0035 and then enter, and it's going to give you, this is what you should see on your screen. It'll be 54.03385.802. Now, right, now we're going to press on the inverse key because we're looking for the payment. We're going to press on the inverse key. Once you do that, this is what you see on your screen. Answer to the -1. Then we press, then we enter 26,750, and then we hit the enter key, and this is how much your monthly payments are going to be. Round it out to your nearest penny will be something like 0.06, 495.06. So these are your monthly payments. Okay. Now let's see how much money came out of your pocket. How much money did you actually pay for the car? Even though the car was 26,750. So how many payments? The payments are 60 payments for $495.06. So let's multiply those. So we got $29,703.60. So how much money did you pay extra, or extra in interest? It's going to give us what the amount came out to, the 29,703 minus 26,750, which was how much the car was worth. So you end up paying about $3,000 extra for those 5 years. And there's a way, guys, that you can eliminate some of the interest was paying extra every month. If you pay extra every month, it will go straight to the principal, okay, which I'm going to show you on the next example. So this example that's coming up will be the last one, and this is how to purchase a house. Okay, example 10. It says here you want to purchase a 325,000 house with a 30-year fixed rate at 3.9% interest. What are your monthly payments, and how much interest did you end up paying? Let's find out. So again, there's a formula, and there's 7 things that we have to keep account of. So again, here, guys, we're looking for the monthly payment, right? So we're looking for the payments. So let's plug everything in. So that's my loan that I got from the bank. That's the percent interest, which would be 0.039. My M will be 12, right? Because it's always monthly payment, so it's going to be 12. The T will be 30 for 30 years. The I will be R divided by N, which would be 0.039 divided by 12, and it will give us something like 0.00325. And the N will be N times T, which is 12 times 30 will give us 360. Let's plug everything into the calculator. There it is. Into the formula. Now let's begin by using one steady flow of the calculator without leaving without pressing clear. So again, we're going to enter what's here on top as the numerator, and the number in black is the result. So it should be 0.6890436,901. This is what's in your screen. Then we press on the division key, right, on this key here, and then we enter the 0.03. This is what you see on your screen. Then we enter 0.00325, and then we get 212.034431. This is what you should see on your screen. This is the answer after you all do all this on the right side. That's what you should get. Then you're going to press on the inverse key, right? Then this is what you should see. Then you're gonna put 225,000, enter, and it gives you your monthly payments. Round it out to your nearest penny. It's going to be something like 1532.92. That's your monthly payment. So the next thing, guys, that's going to astonish you is how much you end up paying in reality. Remember, the house was $325,000. You make 360 payments at $1,532.92. So right, so this is the amount you end up paying. Imagine, guys, you end up paying $551,851.20. So how much interest did you pay? Okay. So we subtract the original amount from the $551,851, right? So we get $226,851.20. So you end up paying that much extra, which is almost a little bit over of a $250,000. Now, how can you eliminate the total interest? You can do it, guys, by actually paying. If you have extra money, pay straight to the principal. You make your payment, right? You make this payment every month, and then plus, if it's allowed, you put in like another extra amount every month, extra amount every month, every month, every month. This way, it begins to eat at the interest that you were supposed to pay. And eventually, if you put in $1,000 extra every month, and you can afford it, then more likely you're going to cut the interest in half. Okay. I just, no, well, I'll share the story later, guys, but this is how you relate math into the real world. And every time that I teach chapter 5, all the students are with their eyes wide open, because this really hits the real life, how they're, because they can relate to this. Most of the times it's hard for students to relate to math, and they tell me, Mr. Sassi, how does this apply to math and stuff? And at times I mention how it applies, but most of the times they lose interest. But when it comes to chapter 5, everybody's interested, for the reason that it affects your pocketbook, and nobody wants to pay extra money, right? So that's why they even ask me questions, how to do certain things, and I share my life, experiences dealing with purchasing houses and cars and stuff like that, and I told them what I did to establish good credit and stuff like that. So I really enjoyed this chapter with my students, and hopefully, you guys enjoy this workshop that I presented today. Okay, that's it for this workshop, guys, and thank you for staying like 4 or 5 minutes extra. Let me go back and to the home page here.
At this time, does anyone have any questions for Mr. Azasi? All right, then I would like to thank Mr. Azasi for coming and presenting for us today. And I would like to thank the audience for being here with us. So next week, we're on March 11th at 1 p.m. We're going to have the EPCC libraries and the Writing Center come with us for a presentation. And then at 3 o'clock for Happy Math Hour, we'll be going over exam review 2. So be sure to come and see us for that and get ready for your test. Thank you all for coming today. I hope you all have a wonderful weekend.